Welcome to the channel Learn and Let Learn. This is the third video of the series. Today we are going to see trigonometric identities. It's like basic formulas you can consider, like this. You might say B is equal to plus or minus whatever quadratic formulas you have. Similar to that, you have identities here. So there are three basic Pythagoras identities in class 10. Actually, these are the basic identities with which a lot of identities are formed. So Pythagoras identities are just three. They are sine square theta plus cos square theta equal to 1, as shown here. Sine square theta plus cos square theta equal to 1. Sorry, it's actually 1. It's theta here. So we have, and that is, I will write it as 1 plus tan square theta equal to secant square theta. It will be easy for you to understand. Similarly, you have 1 plus, see here, same, I didn't write anything. I shifted this tan square this side. It is 1 plus tan square theta. When you shift cos square this side, it is 1 plus cos square theta. Okay. Similarly here, 1 plus cot square theta is equal to what? Cosecant square theta. So this is 1, this is 2, this is 3. What are these three? These are called as identities. What is an identity, first of all? An identity is where you have, suppose A equal to B. It's an identity which is showing A is equal to B. It's an identity. Both are identical. Okay. This is what is identity means. So we have these are, and these three are called as Pythagorean identities. Pythagorean identities. You'll see why these are called as Pythagorean identities is because you will use the basic Pythagoras theorem you have been studying since your class 7 or class 8, where here, suppose this is 90 degrees, where AC is the hypotenuse. AC square is equal to AB square plus BC square. This Pythagoras theorem will be used to prove these identities. That is why these three, or else like these three identities are derived from this Pythagoras theorem. That's why they are known as Pythagoras identities. Let us prove them. So let us first take sine square theta plus cos square theta, and I want to find out what is the value. Is it really 1 or am I bluffing to you? Okay, let me take the triangle ABC where this is 90 degrees, and now what I'm going to do is, now I will write Pythagoras theorem for this triangle is hypotenuse square is equal to squares of sum of squares of the sides, right? So we have Pythagoras theorem here. What I'm going to do is I'm going to divide it with AC square on the both sides. Okay, AC square by AC square equal to AB square plus BC square by AC square. I didn't do anything. I just divided both sides by AC square. Now what? AC square 1 are is AC square. It is 1. Okay. Now I have 1 is equal to AB square plus BC square by AC square, right? I'm gonna do it. I'm gonna split because by plus symbol is here. So AB square by AC square is equal to BC square by plus BC square by AC square. Okay, 1 is equal to AB square by AC square plus BC square by AC square. Okay, from this triangle, what is sine theta? We know this is perpendicular by hypotenuse. Perpendicular is AB, hypotenuse is AC. Okay, and what is cos theta here? Cos theta is base. Hypotenuse, what is base? It is BC. What is hypotenuse? It is AC. Cos theta is BC by AC. Okay, so BC by AC. This is AB, so this can be written as AB by AC whole square, right? And BC by AC whole square. So from here, cos theta and sin theta, you can write that as, you can write this as what? 1 is equal to AB by AC is sin theta. So I'm going to replace it by sin theta. and BC by AC is cos theta. I'm going to replace it by cos theta. Hence, this identity is proven from Pythagoras theorem. It is one of the Pythagoras identities. Let us prove the other one. Same. The procedure is similar for all the three. All you have to do is take the Pythagoras theorem, then apply some divisions, and then you'll get the identity here. It's like cross multiplication, multiplication, division, and all. Same. So what is it? Pythagoras theorem: AB square plus BC square equal to AC square. So earlier we divided with by AC square. Now you tell me. So now let us take BC square. Okay, I'm gonna divide both the sides by BC square. I don't know what the result will be, but that will be one of these three, one of these two, because this is done. One of these two identities. So I'm dividing by BC square on the both sides. So I will end up as AB square plus BC square plus BC square by BC square by AC square by BC square. Okay, so 1. So it is nothing but AB square by BC whole square plus 1 is equal to AC by BC whole square. I just bracket. So now what? What is AB by BC? So I have AB and then BC. We know that tan theta is equal to perpendicular by base, which is nothing but AB by BC. This is theta, so this is perpendicular, this is base. Okay, so we have AB by BC as tan theta. We have tan theta here. What is AC? What is AC by BC? Okay, what is AC by BC? We don't have. We know that sin theta is equal to what? AB by AC. Cos theta is equal to BC by AC. Tan theta equal to what? AB by BC. What AC by BC is unknown. AC by BC is unknown, but we have BC by AC, which is reciprocal of cos theta. We know that reciprocal of cos theta is secant theta, which is nothing but AC by BC. Okay, so we have AC by BC as secant theta. Okay, so finally we have got our identity. 1 plus tan square theta is equal to secant square theta. Okay, so this is second one. It's proven. And this, so to get into this form, I'm going to shift tan t square theta is this side. So 1 is equal to secant square theta minus tan square theta. So finally what is left? I have done with AC square, I am done with BC square. Finally now if I divide with AB square, I'm going to get secant, that cosecant square theta minus cos square theta equal to 1. Let us look at that. Okay, we have AB square plus BC square is equal to AC square. So what were done? I did AC square, I did BC square. This is done. This is done. Now left is AB square. Now we will do it with AB square. Okay. So I will do it with AB square by AB square. Now it will be 1 plus BC square by AB square is equal to AC square by AB square. 1 plus BC by AB square is equal to AC by AB square, which is nothing but, what is BC by AB? So this is A, B, C. What is BC by base by AB is cot theta, right? So 1 plus cot square theta is equal to, what is AC by AB? We know that sin theta is equal to AB by AC. So that implies cosecant theta is equal to AC by AB, right? Because sine and cosecant are reciprocal. So AC by AB is nothing but cosecant theta, since square is there, this cosecant square theta. So finally we have our identity. 1 plus cos square theta is equal to cosecant square theta. So all the three identities have been proven, and we have been using only Pythagoras theorem, and that is why they are known as Pythagorean identities. Okay, this is third video. Thank you.